Okay, in this video we are going to look at methods to make carboxylic acids. Now there are several reactions that we've seen before, and we're going to touch on those first, and then we'll look at a couple of new ones. Alright? And then at the end of the video we will actually use those and apply them in the synthesis of a couple of carboxylic acids. So we'll generate our own synthetic react. Okay, so let's see if we can remember. One way to make a carboxylic acid is simply from a primary alcohol. Now, what sort of a reaction is this, would you guys think? Here is the acid that we want, and here is the alcohol that we're starting from. Well, we're adding oxygen. This is an oxidation. Now, does anybody remember what the reagents are for this? Well, we need a strong oxidizing agent here because we're going all the way through the aldehyde. So we need our strong oxidizing agent, which is our chromium oxide with the acid catalyst. We said that goes through the aldehyde stage, so that also implies if we were to start from an aldehyde and go to the same thing, we would use exactly the same reagents, chromium oxide and H3O plus catalyst. So those are two reactions that we've seen already. And there is actually one more that you saw in Organic Chemistry 1, and it was actually specifically for aromatic formation of aromatic acids, or specifically formation of benzoic acid. So let me draw out our benzoic acid here. This R group is just some carbon group. That should be a 2H there. It looks like a 1. Let me draw that out again. That should be a 2. Sorry for my horrible numbers here. Let me try that again. CO, 2H. Alright. Now, who remembers what that reagent is to take us from that R group to that benzoic acid? It's another oxidizing agent. It's one we haven't seen for a while. It's potassium permanganate. Alright? And that will just happen in water. Okay? So, two methods for oxidation to get to carboxylic acids, and so there is nothing new there. We can actually use a reaction we have seen several times before now, the Grignard reaction, to make a carboxylic acid. Now, usually we use Grignards to make alcohols. We can always oxidize an alcohol to a carboxylic acid after we've made it, but there is a way to directly make a carboxylic acid from a Grignard reagent. So let's say we have our Grignard reagent here. This is our phenyl magnesium bromide, and I'm just not showing the MgBr plus just to save time. Now, if you remember, we have always shown the Grignard reagent attacking a carbonyl electrophile, a carbonyl containing electrophile. And so what I'm going to do here is I'm going to show you one carbonyl containing electrophile that can directly form a carboxylic acid from a Grignard reaction. There's our carbonyl. And if I put this down here, what molecule do we have here? Well, we have a funky looking oxygen there. Let me just get rid of that. Let me try this again. What is this molecule? Well, if you know anything, you'll know that it's carbon dioxide. And you can certainly tell there are carbonyls here. There's just two of them. So that nucleophile attacks the carbonyl carbon as it always does. Alright, so there's really nothing new here. And so what we end up with is our Grignard reagent that now has the O minus and the carbonyl group that nothing happened to. And so what do you guys think the second step here is? It's actually the same second step as in any Grignard reagent or any Grignard reaction, and that's just protonation through H3O plus. And so you can imagine the mechanistic step right there. And so what we get to is I've drawn the product out a little bit differently here, but it doesn't really matter. What we have here is our carboxylic acid. Now I started with a benzene nucleophile here. We've seen Grignards before. This can be any R group. So simply step 1 is addition of the electrophile, which in this case is carbon dioxide. And then step 2, which was seen before, is just protonation. All right. Remember, we always form a carbon-carbon bond in the Grignard reaction, and that is exactly what we've done here. The only difference here is we usually form an alcohol. Because we had 2 carbonyls to begin with in our reagent, we have 1 left in the product, and so that is our carboxylic acid. Now, I'm going to introduce you guys to the one new method of making carboxylic acids that you haven't seen before. And it's actually making carboxylic acids from this functional group. Now, who knows what that functional group is? Who knows what this functional group is? Once I get these, oh crap. It's alright. I don't know what it is about, oh, that end's gone a little bit wonky. Alright, okay. Here's, well, what is that? It looks kind of like it's got leprosy or something, but that is a nitrile. Okay. And let's say we wanted to make the corresponding carboxylic acid from that. So let me try and draw that out and make it look less spazzy. So there's the corresponding carboxylic acid. Notice the number of carbons hasn't changed, 4 and 4. It's actually, as far as the reaction goes, it's very simple. This, you can actually undergo nitrile hydrolysis simply by throwing the nitrile into acid. The actual mechanism of this is somewhat involved, and it's several steps, and that's going to be the subject of my next video. But for right now, this is one other reaction to go from a nitrile to an acid. Okay, so let's just review here. Oxidation of primary alcohol, oxidation of an aldehyde with our chromium trioxide. Oxidation of the side chain on a benzene to give the corresponding carboxylic acid. That's 2 methods for acid preparation. The third is Grignard reaction with carbon dioxide. And then the fourth is acidic hydrolysis of a nitrile. Now, let's see if we can actually apply some of these reactions to the synthesis of some carboxylic acids. All right, let's see what we can do. So I'm going to put up a synthetic reaction here. And let's say, for example, we would like to make, or this is what we're going to start with, okay? We are going to start with this compound here. Now, who knows what this compound is called? Whilst I'm drawing out the product, see if you can figure out what the name of that molecule is. It has a very simple name. And if you can remember the name of this group right here that I'm trying to put dots around, if you can remember the name of that group, then you can name that molecule. It's something bromide. Any takers? The name of that is benzyl bromide. You remember benzene with a CH2 in it is a benzyl group, so that is benzyl bromide. Now, what if we wanted to make this molecule? All right. What if we wanted to make this? So we have taken the bromine and essentially replaced it with an acid group. Okay. But notice, though, in doing so, can anybody tell what I have added to this molecule going from here? Well, the tip is count up the number of carbons in this starting material, and if you count them up, you'll see there are 7 carbons here. How many carbons are there in this product? Well, there's 6, 7, 8. So we have added a carbon. And what reaction does that suggest to you? It begins with the letter G. Of course, that reaction should be Grignard. Grignard reaction is, of course, one way to make that. So let's see if we can try that. If we're going to go from here to here, what would we have to do first to our benzyl bromide? I'm just going to put the steps up here. I'm not going to go through the mechanism. We need to do the Grignard reaction somewhere, and we have to make our Grignard reagent first. So we have our alkyl halide here. So what do I add to that benzyl bromide to make my Grignard reagent? Give you a hint, it's a metal and it begins with magnesium. That's going to make our Grignard reagent. Now in the second step we're going to add in our carbon, as we always do with the Grignard reaction, but we want to have a product that has a carbonyl left in the product. Now we all know that one of the carbonyl groups is used up in the Grignard reaction, so we have to have something that starts with 2. And the only molecule that we know of that contains 1 carbon and 2 carbonyl groups is carbon dioxide. So if that's the second step, then what's the third step? What is the last step in every Grignard reaction? It's always the same. I'm assuming you guys are shouting out protonation, protonation. And there we go. Those are the 3 steps. You guys know the Grignard reaction is 2 steps, but this step here is just to make the Grignard reagent. Now, what if I said, well, I'm going to be a little bit of an arse, and I'm going to make you devise a synthesis for this molecule, starting from here, but the Grignard reaction is outlawed. I'm not going to let you use it anymore. We've used the Grignard reaction too many times. It's getting old. Oh, crap. That line didn't turn out very well. Sorry. I got rid of my 3 there as well. Balls. All right, okay. Let me just finish off that 3. Okay, now I'm going to put my... Well, bollocks again. All right, sorry. All right, let me just erase this bloody thing. All right, so if we can't use the Grignard reaction to make our product, we still have to add in a carbon. What methods do we know, have we learned to add in a carbon that are not the Grignard reagent? Well, the reality of the matter is we haven't. So what do? Well, we could give up and say, well, I don't know, therefore I quit. I'm going to give you guys a hint. Let's go back a slide. Okay. Take a look at this functional group here. This is a nitrile, and you can see it contains 4 carbons. One of those carbons is actually part of the nitrile. So what's the possibility of us maybe adding a carbon to this via adding in a nitrile? Maybe a nitrile nucleophile or something like that. Now, what do you guys think the nucleophile would be to form something like this? Well, of course, the nucleophile would have to contain carbon and nitrogen. And where would the negative charge have to be? Well, we want to form the bond at carbon, so the negative charge would have to be on carbon. Now, what's the name of that nucleophile? Of course, it's cyanide, Cn-. Now, the thing that's particularly important about this, my electrons there, just so you can see, those shouldn't have linked up, bloody thing. The one thing that I'm hoping that you can recognize here is when this nucleophile comes in and attacks that carbon and kicks out that bromine, let's draw out the product, because I want to see if you can spot what has happened here that's of actually very large importance, whether you realize it or not. Here's the carbon that we had before, and then this is the carbon that we've just added in. Okay. Can you guys tell what we've done without necessarily realizing it? What have we added to our molecule? Count up the carbons here. We have added in a carbon from 7 carbons to 8. And we just saw on the last slide, to go from a cyanide to a carboxylic acid, we can just throw in some acid. Through the mechanism we're going to see in a subsequent video, we just acidify that to get to our carboxylic acid. So, one other method to make a carboxylic acid. And what's of particular relevance here is this is useful for if you want to make an acid from something like this and add in a carbon at the same time, if for whatever reason you can't use the Grignard reagent. Now, this reaction is going to be important later on, because we're going to be making amines from things like this, so we have to have nitrogen introduced. But for right now, consider this another reaction to make a carboxylic acid and add a carbon to the chain whilst you are doing it. Okay? And why don't we have a look at one more? Let's see if we can do just one more before we go. Well, before I go. You're still staying around. Okay, I'm waffling. All right, okay, so let's say we want to start with this. 1 bromopropane. And we want to make from it this, which is butanoic acid. What I want you to do is to give me 2 methods to make it. All right? Now, I'm not going to tell you what those 2 methods are. I'm going to let you guys figure it out. But if you can follow what we've done on this video, 1 method here, 1 method here, this being step 1, this being step 2 here, method 1, method 2. If you can follow those, you'll see that these are actually very similar. 1, 2, 3 carbons, 1, 2, 3, 4 carbons. So the principle here is the same. We have added in 1 carbon. All right, Grignard, or in this case, addition of cyanide and nucleophile followed by acidic hydrolysis. Those will be the 2 methods. But what I want you guys to do is to write down those reagents. I'll put 2 arrows here for you, so you can put 2 different sets of reagents. All right, and just figure it out. Okay, that's enough for today. Thank you.